Hey everyone, and welcome back to the channel. Today we are diving into a fundamental concept for handling the ever-growing mountain of digital data, which is object storage. Like think about it, millions of photos on your phone, countless videos streaming online, and tons of documents being shared and stored every second. Traditional ways of storing these data, like organizing them in folders on your computer or even using older server-based systems, can quickly become a nightmare to manage and incredibly expensive as well as that data explodes. That's where object storage steps in as a hero. It's a highly scalable, super cost effective, and incredibly resilient way to handle these massive amounts of what we call unstructured data. Things that don't neatly fit into rows and columns like in a database. In this video, we are going to explore the fundamentals of object storage, how it works behind the scenes, its key advantages, and the many ways it's being used today. So let's get started. So, what is object storage? Unlike traditional file storage, which organizes data in hierarchical structure of folders and files, or block storage, which divides data into fixed size blocks, object storage treats each piece of data as a self-contained object. Each of these objects typically includes three key things. Number one, which is the data itself. Um, this is the actual content, like your photo, your video, or your document, whatever it might be. Number two is the metadata. This detailed information about the data. Think of it like tags or labels that provide context. This can include things like the creation date, the file type, who owns it, and even custom tags you might add. Number three, a unique identifier. This like a permanent and globally unique address for the object within the storage system. It's how the system finds and retrieves your specific data. Okay. There's other thing that we need to talk about, which is the flat namespace. The crucial difference between traditional the crucial difference from the traditional file system is that object storage uses what we call a flat namespace. Imagine a giant warehouse floor, and instead of a multi-level filling cabinet, all your objects are stored in this single vast space, and they are located using their unique identifier, not a complex path folder. As you can see here, like there is no complex path folder. You have to go like a tree from the root to the children. This flat structure is what makes object storage so much easier to scale and manage when you are dealing with truly enormous amount of data. Okay, we talk about some key characteristics of object storage. The first thing we need to talk about scalability. Object storage systems are designed with several really important features in mind. One of them is the scalability. This is a big one. Object storage can easily scale out to store petabytes. That's millions of gigabytes, or even more than that, which is even more mind-blowing. You can simply add more storage, which is nodes, to the system as your data grows, without the limitation you often encounter with the traditional system. Number two, we have cost effectiveness. Object storage is generally very cost effective. This is often achieved by running on readily available standard computer hardware. It's like that, and by using smart ways to distribute and replicate data, which we will talk about in a bit, to optimize storage usage. Number two, we have resilience and durability. Losing data is a nightmare. Okay, object storage systems are designed to incredibly resilient and to be incredibly resilient and durable. They are they use techniques like data replication and error correction to ensure that your data isn't lost, even if individual storage components fails. It's like having multiple copies of your important files spread across different secure locations. And number three, we have rich metadata. Remember those tags we talked about? The extensive metadata associated with each object allows for much more advanced searching, indexing, and overall management of your data compared to just rely on a file name in a file system. You can search for all photos taken in a certain year or all videos tagged with a specific keyword much more easily. And the thing that we talked about, which is the flat space name, as we discussed, the flat structure makes managing data at at a massive scale much simpler. You don't have to navigate complex folder hierarchies, and finding an object is always a direct lookup using its unique identifier. Okay, let's try to understand how object storage works. So at high level, object storage systems is made up of many storage nodes that work together in a distributed way. First, we have a client request. Let's assume this client sends requests. So when you want to store, retrieve data, your application, which is the client, communicates with the storage system through API. These are often RESTful APIs, which are a standard way for different software systems to talk with each other over the internet. Next, we have the API layer or the gateway layer. This is the brain of the operation. The API layer receives your request, handles things like verifying who you are, which is to authenticate you, and then figure out where to send your request within the storage system. And lastly, here we have the storage nodes or the object storage layer. This is where the actual data is stored. The data is spread out across multiple storage nodes in a distributed fashion. Each node is responsible for holding a portion of the overall data. So to reiterate, every object in the system is a self-contained unit. The data itself, all that useful metadata, and that unique identifier that acts as an address. Okay, we need to talk about some other things. For example, scalability and distribution. One of the key reasons object storage scales so well is how it distributes data. Techniques like consistent hashing and sharding are used to evenly spread objects across all the available storage nodes. This ensures that no single node becomes a bottleneck as the amount of data grows. When you need to retrieve an object, the system uses its unique identifier to quickly locate which node or nodes hold that data. Number two, we have data durability and replication. We talked about durability earlier, and object storage systems take this very seriously. A common way to achieve this is through data replication. This means that each object isn't just stored on one node. It's stored redundantly on multiple nodes, and sometimes even in different physical locations, which is different data centers. For example, a system with a replication factor of 3, for example, will store each object on 3 separate storage nodes. So even if one of those nodes fails completely, your data still safely accessible from the other two. This level of redundancy provides excellent protection against data loss. And next we have consistency model. When you write a new data to an object storage system, it needs to be reflected across all those replicated copies. Many object storage systems prioritize eventual consistency. This means that after a write operation, it might take a little bit of time for all different copies of the object to be uploaded. However, eventually, all the copies will be consistent. Eventual consistency is often a trade-off made to achieve high availability and scalability. It's perfectly acceptable for many use cases like storing and serving media files, where all slight delay in seeing the very latest version isn't that critical. However, some object storage systems also offer strong consistency options for applications that absolutely require immediate consistency across all replicas. This can sometimes come with a slight performance impact, but ensures that every read operations return the most up to date. Yeah. Next, we need to talk about a common use cases for the object storage. The first one, we want to talk about cloud storage services. Cloud storage services, like you're likely using object storage every day without even realizing it. Major cloud storage providers like Amazon S3, Google Cloud Storage, and also Microsoft Azure Blob Storage are all built on the principle of object storage. They provide highly scalable and cost-effective ways for individuals and businesses to store all kinds of data in the cloud. Number two, we have content delivery networks. When you access websites with lots of images and videos, chances are that content is being delivered to you through a CDN. CDNs rely heavily on object storage to effectively store and distribute static content like those images and videos across network of servers located geographically closer to users. This makes websites load way more faster and provide a better user experience. Also, they're being used in backup and archiving. Object storage is an ideal solution for storing large amounts of historical data for backup and archival purpose. Its cost effectiveness and high durability make it a great place to keep data safe for long term, whether it's for compliance reasons or disaster recovery. And number four, we have big data analytics. When you are dealing with massive data sets for big data analysis and processing, object storage provides a scalable and flexible place to store all that data, to store all that unstructured data. Things like sensor reading, social media feeds, and log files before it's processed and analyzed. Okay, let's conclusion. Object storage has truly become a fundamental building block for modern, scalable, and resilient data systems. Its ability to handle vast amounts of unstructured data, combined with its horizontal scalability, cost efficiency, and high durability, makes it the go-to solution for a massive range of applications, from the cloud storage services we use daily to the complex infrastructure that powers content delivery and big data analytics. By understanding the core concepts and principles of object storage, from its flat namespace and rich metadata to its distributed architecture and smart replication strategies, you are now better equipped to understand how modern data systems are designed to handle the ever increasing challenges of large data management. So yeah, that's it for this video. If you like this video, please like, subscribe, and yeah, see you in future videos.